So this is the third video now I've done on the topic that I call Bayesian Mythicism, largely popularized by fringe historian Dr. Richard Carrier. I'm kind of assuming you've seen my last two videos first, link in the description. In my first video, I basically accused the Bayesian mythicists of employing what Rational Wiki calls pseudo-statistics, or the use of statistical buzzwords in an inappropriate manner. I then went through how a real statistician would go about testing mythicist claims. In my second video, I actually tested some mythicist claims, specifically those related to the Rank-Raglan mythotype. I built a 60-some personage dataset, about half historical, half not. I computed a Rank-Raglan score for each, I computed a Rank-Raglan score for Jesus, and I ran a logistic regression algorithm. There was no statistically significant correlation between Rank-Raglan score and historicity, or between Rank-Raglan score and having been euhemerized, but there was a statistically significant correlation between Rank-Raglan score and royalty, which is an historicist claim. We also conclusively rejected the claim that Jesus' probability of historicity based on Rank-Raglan score was 33% or less. And we rejected the claim that the probability of Jesus having been euhemerized based on Rank-Raglan score was greater than 50%. Because even if we granted statistical significance, which remember, we do not, Jesus would have needed a Rank-Raglan score of 58 and 32 out of 22, respectively, to have had those probabilities. So at this point, Bayesian mythicism, at least as it relates to the Rank-Raglan mythotype, is looking pretty busted. But I recently finished a seminar on non-parametric statistics, and I want to explore these data a little more through that paradigm. See, the methods I used in my initial analysis were, quote, parametric. Parametric analyses make assumptions about the underlying distributions of the data. Methods that don't rely on these underlying assumptions are what we call non-parametric. Parametric methods are more accurate if you are right about the underlying distribution of the data, but they're less accurate if you happen to be wrong. So my logistic regression model was a parametric generalized linear model, and maybe I'm wrong about the underlying distribution of these data. Not too far off, but maybe not 100% accurate. I can do a non-parametric logistic regression using a generalized additive model. I realize those last few sentences didn't make a great deal of sense to people without the background, but the basic idea is I'm trying to create a model that is flexible enough to allow for local deviation from a true logistic curve. While I'm at it, I'm going to do some data exploration using non-parametric multidimensional scaling, which is a non-parametric version of the principal components analysis, as the PCA assumes an underlying multilinear regression model, whereas NMDS does not. Finally, the YouTuber Fishers of Evidence points out that receiver operating characteristic analysis, or ROC analysis, as a means of measuring the accuracy of tests, for example, Rank-Raglan score as a test of historicity, should be performed on these data. So I've done a ROC analysis as well. This one is for you, Fishers of Evidence. But first, let me deal with a few objections that will almost certainly come up. I'm taking no position on the historicity of Jesus here, just demolishing a particularly egregious case of the abuse of statistics. As I said in both of my previous videos, I do think, when they stay away from math they don't understand, mythicism actually has a reasonably compelling case. I'm not going to take a position on Bayesian epistemology here either, though it should be its own video in the future. I largely don't agree with it. I think we can incorporate prior probabilities into binary epistemologies without going full continuous Bayesian epistemology. I'll link a video from the philosophy YouTuber Carneades on the topic of Bayesian epistemology in the meantime. Finally, it is true that I am not an historian. I'm a real scientist. I'm a paleontologist whose research concerns paleostatistics, the best methods for analyzing fossil data. Reconstructing the past with math is literally my job. Which brings me to my voice this week. I spent the past week in the field on a dig. I got some great fossils from some Devonian shales, And on the last day, we got caught up in an unexpectedly intense rainstorm. I spent hours soaking wet and muddy, and now I have the sniffles. Okay, so here are the results of the non-parametric logistic regression. You can see it's slightly better than the parametric version, especially around outliers like our good old buddy Mithridates of Pontus. But the error bars are the same, and indeed the output of the GAM package in R reports no statistical significance. Rank-Raglan is extra irrelevant in the historicity discourse. Just for funsies, I tried the same thing with the smoothing spline algorithm, and got the same results as the parametric model. Now let's look at the ROC curve. The diagonal line represents the error rate if you were to assign historicity by flipping a coin. The closer the colored line is to the top left, the better the test. We can see that the non-parametric Rank-Raglan model is a marginally better test of historicity than the parametric version, but both are not significantly better than historicity test by flipping a coin. Finally, R and MDS shows some similarly ambiguous clustering to the PCA. Of course, these axes don't seem to account for a lot of variance, and it may be that we need to generate more data in order to get a bigger signal and account for more variance in both systems in order to get a clear result. Well, that's it for this time, comrades. The semester's almost over, so I'll be going home to convalesce for a while, both from my head cold and from the stress of passing my doctoral candidacy exams. Auf Wiederhören, mein Freunden. Tschüss.